Hi guys. Alright, so we're looking today at second lesson of additional functions, moving on from absolute value functions now to looking at a new type of function called square root functions. A square root function is always going to take on this shape. It's going to start at a point and it's going to go kind of like up and over. We're going to work off of the same concept of there being a parent function, like a most basic version of the square root function. And what that looks like is this. You're basically going to start at the origin with a point. And you don't have to draw this table of values. I'm just showing you where these points come from. But if you take the square root of 0, that's 0. If you try to think of the next perfect square, you can take the square root of 1, which is 1. So if I go over 1, up 1. The square root of 2 is irrational. Square root of 3 is irrational. So I'm going to skip over 2 and 3, and I'm going to go to 4. The next perfect square, the square root of 4 is 2. So if I go across 4, 1, 2, 3, 4, and up 2, that gets me to my next point. I'm not going to put in 5, 6, 7, or 8 because those are all irrational numbers when you take their square root, meaning that they give you these decimals that are infinitely long with no repetition, and those are hard to graph. So I'm only going to graph the ones, plot the points that are perfect squares. So the next perfect square is 9. The square root of 9 is 3. So if I go across 9, this was 4, 5, 6, 7, 8, 9, and then up 3, 1, 2, 3, that's another point on the graph. And if I connect them, that allows me to graph the square root function. So I personally am not going to be making this table all the time. I'm just going to count over 1, up 1, over 4, up 2 because of that point, over 9, up 3 because the square root of 9 is 3. Keep in mind that we are still graphing like square root of 2, right? That's over here. We didn't plot that point. Square root of 2 is this decimal over here. Square root of 3 is this decimal value over here. Square root of 4 is, well, we did 4. Square root of 5 is here. Square root of 6 is here. They are on the graph. We just didn't show them as points. We didn't use them to plot the graph. But since it's connected, those points are all included in the parent function. So that's the parent function. And then from there, you're basically going to do translations like we did yesterday. So that means that if you look at example 2 and they say square root of x plus 3, if the number that's being added is outside of the square root, this is a translation or a shift. You're translating it up 3 units. Okay, or a shift up 3 units. So you're basically going to start the same way as we did yesterday, where you're now counting from the origin. You're going to go up 3, 1, 2, 3. Now, instead of having your initial point at the origin, it's going to start there. Now, from there, you're going to basically go over 1, up 1, because the square root of 1 is 1. And then from that starting point, over 4, up 2. 1, 2, 3, 4, up 2, because the square root of 4 is 2. And then from there, over 9, up 3, because the square root of 9 is 3. So if I go from there, that was 4, 5, 6, 7, 8, 9, up 1, 2, 3. Okay, and you should label. I didn't label the last one, I think. Okay, and then in example 3, same idea. This time you're shifting down 5. That says down 5. So you're going to go down 1, 2, 3, 4, 5. And then from that point, over 1, up 1. Over 4, up 2. 1, 2, 3, 4, 1, 2. Over 9, up 3. 5, 6, 7, 8, 9, 1, 2, 3. Again, because the square root of 4 is 2. The square root of 9 is 3. So you're just shifting the parent function. Okay? Now, if you have a number adding or subtracting inside of the square root sign, like in example 4, you have a 4 being added inside of the square root symbol. This is kind of like, it works like the absolute value did yesterday, where it's sort of opposite world in there. So it's left and right, but you would think positive 4 would take you right, but it doesn't. It shifts you left. This is a shift left 4 units. So you're going to go 4 to the left from the origin, 1, 2, 3, 4. And now that'll be your starting point. And from there you go over 1 up 1, because the square root of 1 is 1. And then from there you go over 4 up 2. 1, 2, 3, 4, 1, 2, because the square root of 4 is 2. And then from that initial point, you go over 9 up 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. And that's my square root function. Now, if I could, the next perfect square after 9 is 16, right? So if I could, I would count over 16 up 4, because the square root of 16 is 4. Now, example 4 is a repeat, so skip over that. Example 5, they are subtracting 3 inside of the square root. So again, if it's inside of the square root, it's left and right, but it's opposite of what you would expect. This is shifting you right, 3 units to the right. So you're going to go 3 to the right, 1, 2, 3. That's your starting point. You're going to go over 1 up 1, over 4, 1, 2, 3, 4 up 2. And here I don't have room to go over 9 up 3. So I'm just going to stop there and draw my arrow. Y equals square root of x minus 3. All right, that's it. So it's really just like yesterday with absolute value, only now applying it to square root. And just as an overview here of translations, if you look at this box, if you have the square root of x plus h being added on the outside, this is a shift up h units. If you have the square root of x minus h outside of the square root, it's a shift down h units. If you have k adding inside of the square root sign, then you're shifting left k units. And then if you have k subtracting inside of the square root sign, it's a shift right k units. All right, and you'll practice some of these tonight for homework. Oh, actually, you know what? Before I let you guys go, just you'll see possibly combination ones. So just to do one of those before I let you go. A combination would look like example 6, where you're doing a shift up and down, up or down, and then left or right. So for instance, on example 6, you're going, the plus 1 takes you to the left 1, and the minus 5 takes you down 5. So you just go left 1 and then down 1, 2, 3, 4, 5. That's your starting point, and then you follow from there. Over 1 up 1, because the square root of 1 is 1. Over 4, 1, 2, 3, 4 up 2, because the square root of 4 is 2. And then from that initial point, over 9 up 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 up 1, 2, 3. And that's how you do the ones that have like 2 steps. All right, and you just have several of these for homework. I am not doing the ones that have, like, if you look at example 8, there's a 2 in front of there. I'm not doing those with you guys. I'm going to stick to the simple ones where there's no coefficient in front of the square root. So it should be pretty straightforward. All right, thanks.